Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
Right, hello. Okay, today we're going to talk about AWS. Specifically, we're going to talk about how Amazon kind of screwed over my original idea for this talk. We were doing some interesting things in our project, and I submitted a talk idea for this, and at the time, so I've just noticed this is auto-advancing, which is going to make my life a little bit difficult, but might make me run to time, which would be good. Pretend you didn't see the amusing joke there, and we'll just start again. Okay, so we were doing some cool stuff with the auto-scaling work, the deployments, a bunch of different Amazon services, hosting quite a complicated package on there. And around about the time that I started putting all of this together, Amazon bought out Elastic Beanstalk, which is kind of their full stack solution for all of this. It lets you deploy an application into a scalable environment and rapidly connect with all the other services. So what that meant was all the stuff I was going to tell you was kind of made defunct because I would look like an idiot who was just reinventing the wheel. So instead, I'm going to look like an idiot for a number of other reasons, which you will see. So I went ahead and just deleted the presentation that I had there and decided that what I was going to do is just hack up an example for you guys that uses Beanstalk, uses a bunch of the services, and shows you hands-on how you can really make all of this work and what kind of problems I ran into, what kind of hacks I had to find to make it work properly. Now, I got unfeasibly excited about this because it was like I was just doing dirty code, and it was fun. So I make no apologies for we are going to stay in the command line the entire time. We're going to do everything through this. So if you feel yourself falling asleep, or if you're not excited by code and by command line tools, then, I don't know, run now. Okay, so first up, a little bit about me. If you don't know how to finger yourself, then just type in man finger, and everything will be explained. Please don't ask me questions about this afterwards. So a little bit about me. Software engineer and technical team lead at Invika. We're basically a large PHP consultancy company in the UK. Recently, we are also now Sensio Labs UK, and we have Session Digital who do Magento work. On top of that, we are hiring, so if any of what I say sounds like it's the kind of thing you might want to do, then perhaps come talk to me afterwards. Okay, who uses AWS at the moment? Good. Okay, so AWS has about 1 million acronyms. So I'm not going to go into detail about the services. I'm going to show you how to connect them together. But if I mention something up here that you don't understand, then just put your hand up and I can give you an explanation of what it is. So IAM, or IAM, is the kind of credential management within AWS. So you just create a user for each of your developers or whoever you want to give access to the service. So I've done that, and I've downloaded the files that the dashboard gives me. So in there, I've got the login credentials so that I can actually go to my dashboard, and I've also got the access key credentials so that user Rowan can actually use the services as well. So to do something for you guys, I was trying to think of a cool little application that I could hook up, and normally this involves some kind of play on words, so I thought we could start with Ampster, and then maybe if there's someone here from Facebook who feels like IPOing me for a couple $1 million, then we can do that. So maybe you've got a clue as to what we're actually going to code together. Hopefully the punchline at the end will pay off and you'll be able to play with this and see if it works. My credit card is behind it, so don't go crazy. We do need to test the scaling, though. Okay, so we're going to create our Amsterdam application. And because we want to be like all the cool kids these days, and also I needed to hack this together very quickly, we're going to be using Composer and Silex. There are a couple Composer guys around today, so if you have specific questions about what I've done here, they'll be able to go into more detail for you. So Composer is just a package manager for PHP that kind of rapidly lets you specify minimum requirements for your application and pull in dependencies from a variety of places. So this is a very basic Composer file where I've just given a bunch of information about me and who I am, and then down the bottom I'm saying that I require at least 5.3 and that I need Silex from the dev master branch. So that is going to go off, well, once I install Composer, that's going to go off, and it goes and grabs Silex and its relevant dependencies from the GitHub installation. Once we've got all that in, that gives us this structure in our directory. So we've got our Composer file that we created, and then we've got all the stuff that it's pulled in, the libraries and the autoloader. Now we actually need a site that we can hit, so we're just rapidly going to make a web directory. Now, what I've found quite helpful when I've been playing with Aws Tools is make sure that you include something like a static file that you can just hit to verify that your web server is actually returning files. So in there, we're just going to drop in something like that. And also, I find it's generally quite helpful and just interesting as well to drop in a quick PHP info file so that I can see exactly what's running on my server and that PHP is actually being interpreted. Then we've got our index file. So this is all we need to get Silex up and running. This was the reason I chose this, because there's very little code for me to actually write to show you these things. So I've just turned on a load of error reporting and display errors so that I can actually get some information out of AWS when I mess things up, because I did that a lot. I should probably turn that off, actually. That might explain why it's so slow at the moment. But never mind, we'll get to that in the demo. So I'm just including my app file, which is going to be where I define all of the roots and my actual application and controller logic as well. So we'll take a look at that. We'll make a source directory. And inside of here, we're just firing up the Silex application and pretend you don't see the debugging statement in there. And we're basically just doing a little hello world application. So we're putting it on the get URL. On the hello URL, and it will respond to a GET request, and it will simply return the hello DPC world. So just to remind you, we now have a structure like this. And the nice thing about everything that I've got here, with the exception of a few AWS-specific stuff, I can still test all of this locally just by firing off the standalone web server built into PHP at the moment. So I fire that up and it starts serving from the web directory. So I'm break my terminal into two. Let's make a call request over here to verify that it's actually returning, and hooray, we have a working application. The end. Right, so now we should probably actually try and put this onto AWS and do something useful with it. First thing we do is we fire up a Git repository. So I've just created an empty repo in the Amsterdam directory there. And sort out my git ignore so that I'm just ignoring the eventual cache directory that will be in there, my Composer files, and also all of my vendor files under vendor, because I don't really feel the need to include all of my libraries inside of my Git directory. And we're just going to add all of that. So this is everything we're storing in our directory at the moment. We're going to commit that with our, yeah, I don't think that commit message actually conforms to the kernel standards, but I don't know. I haven't pushed this to GitHub yet, so we don't have to worry. So that's committed. So now we have a repo. We've got our code in there. We're ready to push this onto AWS to see what actually happens. So the first thing we need to do is you can go to the dashboard and you can just do all of this visually through the website, but the website doesn't have as much ASCII art as my presentation does, so we're just going to pretend that doesn't exist. Plus, this lets us do much more complicated things. If you just do it through the dashboard, then you don't really get an idea of what's going on behind the scenes, which is important when certain things don't work the way you expect them to. So we're going to grab the Elastic Beanstalk command line tools. Those are available on S3, and if you just search for that as well, that will take you to the page. They've got pretty good documentation for that. We're also going to pick up the Ec2 tools, because when you are trying to diagnose problems with Elastic Beanstalk, it's often quite helpful to see the actual Ec2 instances that are running and jump onto one of them to actually poke around at things. We'll unzip those just in our local directory, so you can see that we're getting two packages here. We've got the Elastic Beanstalk CLI tools, which includes all the tools for interacting with the service. Then we've also got the AWS Dev tools, and we're going to see what those do in terms of giving us some repository integration in a moment. And the API tools here. Now, unfortunately, the AWS, the various command line tools, as far as I can tell, I think they've all been written by various groups of people who were really intent on never communicating with each other. So unfortunately, for each tool you download, you kind of have to do all of the setup and configuration separately for it. So this is kind of a pain in the ass, because there's quite a bit of overhead to get this up and running the first time. But once you do have it up and running, you don't have to come back to it again. So mainly, there are a bunch of environment variables we need to set. Obviously, in real life, you're going to stick these into your dot profile or whatever so that they're just there on a permanent basis. So add the tools to our path. We need to get our AWS credentials in a place where the Elastic Beanstalk tools can pick them up. So I've just got this AWS credentials file here, make it relatively secure. Then I export another variable telling the Elastic Beanstalk tools where I've put that credentials file. And then we can test it out to see if we can actually talk to the Elastic Beanstalk system. So this is the first time that we're doing something exciting with AWS. So we run that command, and this is spitting back from the API the available solution stacks that we can use to start up our application. So you can see you've got the Tomcat ones. These have been around for a while because Beanstalk started off as a Java-only solution, and it was only earlier this year, last year, that the PHP stuff became available. There's also IIS there as well, which I guess if you need to run it, but you have no interest in actually being involved with it in any way, this would be a good solution. So this has proved to us that we are actually talking to the Elastic Beanstalk service, so we're good. We can go ahead and start using a bunch of the other tools. Because this is on your path, the way that I worked out most of this stuff was I just typed in Elastic Beanstalk and then double-tabbed, so it showed me all of the available commands. We also need to set up the Ec2 tools, so we're going to do some similar stuff for them, add those to our path. We need to set the Ec2 home directory, because for some reason the tools don't know where they're located and aren't capable of working it out by themselves. We also need to tell it where our JDK is, because these tools are all Java-based. So in my instance, I'm using the Java 7 JDK, but just point that at wherever you have yours. And I also need to create myself an SSL certificate so that I can actually allow my user to hop on to the instances if I need to SSH in there. So again, this is a bit complicated, but if you just look up how to do this, then there are a couple web pages that just take you through each of these steps. So I'm going to create myself a new certificate. I just wanted to get some home city representation in there. This really isn't important. So I create a certificate for myself there. I also need to provide the decrypted version as well. So I've got, yes, my certificate, my private key, and my version over here as well. So I export my private key into yet another variable. I export my certificate. And the other thing that you need to do is you go into the Amazon dashboard, and in the IAM control panel, you just upload your certificate for your user. And then, because we still aren't done with the configuration, we need to actually attach this certificate to a number of key pairs so that we can actually SSH onto our individual instances. So this is just a little script that loops through all of them and just throws your key pair up into every geographical region. So you only need to do it once, and then you can forget about it. So again, there's nothing too interesting going on here, other than we are dealing with the Ec2 tools. So we're just getting the regions out here, and we're also using the import key pair command to fire off our public key off into the relevant region. So we run that, and our keys will now be across all of AWS and ready for use. Finally, we can get to creating a Beanstalk application for ourselves. The Ec2 tools are not brilliant. I think they're quite old in terms of how old any of the AWS stuff is. But the Beanstalk stuff does come with really quite good inbuilt help documentation. So again, before you run any command, I would just do a help like that. So the way the application stack works here is we're going to create an application, we're going to create a version, and we're going to create an environment as well. And I'll tell you how these things link together. Again, in day-to-day use, there are a lot of commands that will allow you to just do this in one because they will automatically create the dependencies. But so I can illustrate where all these things are and how they connect together, I'll show you one by one. So we create an application first. An application is really just a container with a name and a description. That's about it. So we create our Amsterdam application, and we get a response back from the API like this, telling us the name, when we created it, and the description there. Now we need to create a version for our application. So in this case, you can see that we actually start to have some more complicated options in here. We'll come back to these in a bit, but for the moment, we're just going to create a named version because we need a version to fire up our application. So we do that. We're just going to call it initial development version, and we call it version dev001. So we fire that off, and you can see that because we didn't provide it with anything, it's actually given us this default version here, which is the Elastic Beanstalk sample app. And war is a Java application distribution method. Okay. The thing that you are going to be working with the most then is the environment. So the environment is where you actually have all of the stuff like, so a template if you're using, if you have a number of pre-built AWS resources that you want to spin up, the solution stack, which you'll see us add. And this is what represents the actual endpoint you're going to be contacting, where you're going to be hosting your application. The idea of having multiple ones of these is that you would have a development one, a staging one, a production one, a beta one, whatever number you wanted to have for different versions. So we start to get a bit more complicated now. So we're going to create our environment, and we're going to call our environment Amsterdev. We're going to use the Amsterdam application. We want to use this version here. We've got a description, and we're telling it that we want to use the 64-bit version of PHP 5.3. We fire that off, and we get some stuff back, telling us what it's created, telling us a status over there, which is gray, giving us some information about the load balancer, and also giving us status here. This is obviously not very readable, especially when I've expanded my terminal like this so you guys can actually see the text. So another thing you can do is you can tell the describe environments to give you a list of what's going on, and that comes back in this format. But you can also pass the -j option to all of these tools, and they'll return a JSON response to you instead. So I'm just piping this through Python, through the JSON tool, so that I get a formatted version of it. The information you get back with the environment is verbose. So I would suggest piping it to less and just kind of scrolling through to find the bits that you're interested in. Or, of course, we can just pipe it to grep as well. So we'll look for our status, so our environment is still launching. The first time you fire one of these things up, it does take a while. And by a while, I mean probably about 5 minutes for it to actually come up and start working. Here's one I prepared earlier. So our environment is now ready, but we still can't do anything with it, because unfortunately if we do the health check, then it's returning red. So what we need to do is we need to configure it to actually be pointing at something useful, because at the moment we've just fired up an application with a pretend version on there, so of course the health check is red, because we have no idea what code we've just deployed to this thing. Java code. So obviously it's red. So what we need to do is we need to change the configuration of our environment. So rather nicely, in a sort of semi-restful way, you can query the configuration. So we pull this back, and we get a bunch of information. And basically, this is a very long list of option settings where they give you a namespace, an option name, and a value. And if you scroll through all of that, then there are probably about 80 or so configuration options in there. But there are a couple particular ones that we're interested in. So the document root is in there. So we can pull that out. We can see the current document root is just /. So what that means is that in your Git repo, it by default is assuming that you just want to serve right out of the root of your Git repo. The other thing we care about is the instance type. By default, it just fires off a micro instance. This is obviously useless. So we're going to have to do something about that, especially if you guys are going to touch it. And finally, because we went through so much pain setting up our Ec2 keys, we should probably tell the environment that we've done this as well. So what we can do is we can just grab all of those values and paste them back into a JSON file, update it with the values that we want. So we're serving under web. We want a small instance for the moment because my credit limit is not that amazing. And this is the name of the key pair that we created earlier. I did make a typo with the name of the config file and called it answer.dev, but luckily that's just a name of the config file. It doesn't persist anywhere afterwards. So we'll ask the update environment command for its help, and it tells us a bunch of things we can do. So we need to tell it that we want to update the amster.dev environment with the vdev001 version, and we've got the config file located here. So we push that up, and again, we get a response back where it should tell us that it is busy updating the environment again. Once you're past this stage, this is now relatively quick. These updates happen within a matter of a minute or so, sometimes about 30 seconds. So you can do this relatively easily. It's only when you're spinning up an entirely new environment that you need to wait about 5 minutes or so. But our health is still red. And this is because, of course, we haven't actually put any code on there yet. So we've pointed it at the right place, but that's just returning a 404 currently. So we need to get our code up to the AWS server. So we're going to go into our Amsterdam directory again. And what the AWS Tools scripts do that we showed earlier is they basically run, so you need to go into the root of whatever repo you want to publish as your application, run the tool, and it will do some magical integration with Git. You then have the AWS dot commands available to you. So again, if you've got bash completion in your shell, you can just do git AWS and tab and see the stuff that is available to you. AWS config you run for the first time, and that will ask you some questions. And we put in some, I only realized quite recently that I had actually left all of the private details in here and that I should probably gray them out in some way. So inside of here, you go through and you provide all the various configuration details. So the name of the application you want to deploy to, the environment you want to deploy to, which is amster.dev. And that is now set up. So if we do git AWS push at this stage, this will show us that it is taking the contents of our repository and it is pushing it off to the magical unknown location that the AWS config set up for us. So our environment is updating again. It's ready. The health is green. So in theory, this means we should be able to start making requests against it and see something happen. So we'll go back to our describe environment command again, and we're going to grep for CNAME in there, because that is going to give us the location of the endpoint of the Elastic Beanstalk. You can hook all of this into things like actual, use the Amazon Route 53 stuff so that you can use a real domain name here. This is just the auto-generated one that you get. So what we should do is trying to make a curl call against that and see what we get. The suspense really isn't the same when it's a live demo, but I was trying to make this work on the wireless connection here earlier, and that was like the most stressed I've ever been in my entire life. Okay, so we make a curl call against the humans.txt, and we get that back. That's good. We know our endpoint is correctly configured, we know it's serving out of the right route, and we know that we can serve static files as well. So the other thing we should do, and I apologize, this is when I start to get a little bit graphical, because I did try putting this through curl, but it's really not very useful to see the PHP info output through curl. So we fire that up, and we can see that we are actually getting an info page here. By default, they enable almost every extension that you could want on there, so you're unlikely to have to tinker with any of the PHP config if you're just trying to get a development environment up and running. Okay, so that's really cool. So now we should be able to do the hello world on there. So we'll just curl that as well, and that doesn't work. In fact, it just completely doesn't work, because it's telling us that we have no such file or directory in there. This had me scratching my head for a little while, so anyone have any thoughts on what went wrong here?
The vendor directory is empty.
Yep, so we just haven't uploaded anything in our vendor directory because we explicitly git ignored it. Before, I also did that. I didn't ignore the vendor directory, and I uploaded it, but because it's cloning my repo, cloning the dependent repos in there, it still wasn't working, so I had to do a bit of research and found out that AWS push really just expects a flat Git repo. So it will not work with submodules, it will not work with other interesting things inserted into your repo, and fairly obviously it won't upload anything that you haven't actually committed into your repo as well. So we need to do something slightly more involved, but something that gives us a bit more control over the situation. So just to understand what's going on, I'm going to grab something that helps me list my S3 storage. So the S3 command is available through any decent package manager. And again, we need to run some configuration for this, but this is slightly easier than the other ones because we can just do this on the command line. So again, we pop in our details there, we pick a password. Anyway, so that saves it out. I'll be changing that configuration after this. So that saves out our user, and we can now list the contents of our S3 storage. So you can see that I've got 3 buckets in there, and the Elastic Beanstalk US East one has been created automatically when I created my Beanstalk application. So if we take a look at the contents of that bucket, we can see that actually what we've got inside of there are some files that are prefixed with git and followed by a hash. So when you're doing git AWS push, what it's doing is it's basically taking the snapshot of that commit, it's zipping it up, and it's pushing it to S3. And then Elastic Beanstalk is creating a new application version using the zip file that is in your S3 storage and spitting that out onto the instances that it's firing up as part of your application. So luckily, we can do the first part of that step ourselves. We can create a zip file and just put it in the right location and tell Amazon to use that as the version that we want. So we are just going to zip up the contents of vendor, web, and source. We're just going to name it with the current date so that we have a way of easily ordering these. So we run that, and that zips everything up. And if we look in the directory up here, you can see that we've now got a version directory that contains everything we need. If you're playing around with this command to make sure you're excluding certain files or zipping up the right files, one easy thing I found was that I could just go onto my desktop, unzip that again, drop into there, run the web server from the local directory to verify that I had actually got all the files I was expecting. So now what we're going to do is we're just going to use the S3 command again to put that zip file into the Elastic Beanstalk bucket. So that was actually in the middle of a talk, so the Wi-Fi was fairly decent. When you guys came out for lunch, this all went to shit. Okay, now what we're going to do is we're going to go back to the Beanstalk tools, and we're going to create a new application version. So what we do here is we tell it the application that this version is for, which is Amsterdam. We give it a description, in our case, just version from zip file. We give it a label, so this can be anything you want. For ease of reference, I'm just using the first part of the file name so that I've got something sane to refer to. And then you tell it where in S3 it can find the zip file that relates to that version. So we fire that off, and it goes ahead and tells us that it's happily created that new version. So now what we need to do is we need to update our environment to tell the Amster dev environment that we now want it to use this version label. It does that, and we're now updating again. Of course, this is a slightly involved process, so the obvious thing to do is wrap it up in a shell script. So this is what I've done for the end result. I'm basically just doing exactly the same things, but once I had a few more dependencies added into the project, I found that my zip file was actually going upwards of 6 meg. But that was because all of the dependencies had such wonderful tests and verbose documentation. But I thought to myself I really didn't need to put those on a production server. Any questions on that so far? You guys still liking the command line? Yeah, cool. Okay. Everyone's like, no, don't do a code heavy talk, man, not at the end of the day. I was like, screw those guys. Anyway, okay, so let's hop back again. We'll describe our environment. We'll get the CNAME out so that we can ping it again. Ping the /hello root, and woo, we've deployed to the cloud. And we're doing exciting, scalable things. So let's see how we're doing for time. Dino 3. Okay, cool. Right. That's all you need to get something onto the Elastic Beanstalk and start playing with it. So now what this means is just if it's a standard PHP application, then you can just go. You are effectively done here. But I wanted to play with some of the integration that we can do with the AWS toolset as well. So what we're going to do here is we're going to grab, so we're back in our composer.json again, and we're going to grab the AWS SDK for PHP. This is available off of GitHub, but it's just there as a Git repo. However, there is a pull request that they are saying is going to be in a version upcoming soon, but the guy's repo, you can just grab it directly from. So he's added Composer support to it, so you can just get the AWS SDK directly through here. So I've told it where the repo is, and I've told it which one I want and the version that I want as well. This has the benefit of including it in the autoload file, because the documented way of using the AWS services is bizarre. And we'll just pretend it doesn't exist. So I would highly recommend that you use Composer to install this, rather than trying to go through the slightly strange setup that they suggest. Also, because I want to do some cool stuff, I'm going to make everybody wonder why I was using Silex in the first place and pull in the majority of the Symfony dependencies as well. This is just because I need something quick to allow me to do some forms, pull in Twitter Bootstrap and Twig so that I can just show you guys something that looks slightly prettier than what we've been doing already. So we'll update that, we grab a load of stuff, and you can see that now our directory is looking like this. I've added some new files up here. So we are going to take a look at S3 in a bit more detail, the SNS service, which is the simple notification service, and we're also going to take a look at DynamoDB. And we're going to have to do it really quickly if they are clapping in the other room. But the idea of what I want to do here is kind of just blast you with information, leave you with a live demo, and then I am around the rest of today and some of Sunday as well. So if you want to find me and ask questions or want me to sit down with you and go into more detail about the code, then I'm happy to do that. So let's take a look at, oh yes, and in the vendor directory as well, you can see that we've got our other dependencies in there. Well done. So that is the configuration for the AWS library. Basically, again, you give it your key, your secret key. It can do an amount of caching as well. There are different options for that, so I've set it up to tell it to use APC for my caching. Okay, so the app file has expanded quite a bit now. So what we're going to do is we're going to first look at the upload function. So you can see that we are just creating our new image upload object, which is just a simple data object, building a form. I'm not going to really go into detail with this. This is just Symfony. Then down here, if it's a post request, we're going to validate our form. We're going to set a flash message, and we're going to fire up our new Amsterdam image uploader, and we're going to call persist on it. So what is going on in there? In there, I'm firing up the S3 service, and I'm just persisting my image upload to S3, and I'm firing up the SNS service, and I'm sending a notification that the image upload has gone through. Now we're actually to the point where these are the various classes that Amazon is providing for us through the SDK. So I've just followed this kind of pattern of building them like a mapper class, because it let me wrap the commands in a reasonably meaningful name. So we pass in the config, and I've just got a little get function there that builds the S3 object for me by passing the config in. The config is what you saw stored in the config file with all of my private details in it. This is now also another pattern I've done in here is I am initializing all of the resources that I need if they don't already exist. In a real application, you wouldn't do this because it's an unnecessary check. You would just have some kind of pre-install script where you set all of this up in advance. So in here, we're going to initialize a bucket. We're going to give the image we've got a unique name, and then we're calling, this is the SDK command. You can tell all of the SDK commands because they follow the undercase convention, whereas I've been following the camel case one, so it should stand out reasonably. So what we give it here is a bucket, the name that we want to attach to the object, and then you pass an array that give it a number of options. The documentation is pretty good for this. So here we're just telling it that we want to use a file upload from the local file system, which in this case we're getting from the SPL file info here, and the ACL of the object when we put it in there. So by default, when you stick objects into S3, they are private. They can be publicly accessed. So if you want to provide a URL to do something like download an image, you need to make it public. We just test the response is OK, and we get the image name back. The stuff we're doing here to initialize our bucket is we're just checking if it exists. If it doesn't, we're going to create the bucket in the standard region, a public ACL for the entire bucket as well. And then this is another thing with the AWS services. They are eventually consistent, meaning that when you have created something, you should normally sit around and just check and wait until it has actually been created. So this is a definite reason that you wouldn't do something like this inside of your request. You would do this as part of your application setup instead. OK. So now we're back in the main service, and we're going to take a look at what we're doing with SNS. SNS is quite cool, actually. It's the simple notification service, so it's a pub-sub thing. So basically, you set up a topic, and then you can publish messages to the topic, and subscribers receive those messages. They can receive them either to an HTTP and HTTPS endpoint, to an SMS message, or to an email. So inside of here, we're following the same pattern as before. We're just firing up an Amazon SMS object with the config. And then we are creating... Now here, the check create topic, this is actually idempotent. So if the topic already exists, it will just return anyway and have no effect on the system. And we want to get the ARN, which is the identifier for the topic. So in the response here, we go into the body, get the create topic result, and get the topic ARN. The body of the responses are generally returned as simple XML objects, so you can jump into them like this. And then what we're going to do is we're going to publish a message to the topic, and we can pass in, this is the message we want to pass. So for my image upload, it's got a message on there. And we can also use a subject. So the subject, I'm using the S3 name. You are quite limited in here in the number of characters you're allowed to use. I think it's about the length of a Twitter message or so. Ah, yes, because you can send them by SMS, so that would make sense. The other thing we have to do that is a little bit tricky is we have to initialize our subscription. So here, we go in, we list our subscriptions, and we're asking for the subscriptions for this topic because we need to know if our endpoint that is going to process these subscriptions has actually been registered. If it has not been registered, i.e. there are no subscriptions, then we're going to send a subscribe notification, and this is the endpoint. So this is our elastic Beanstalk, and just so that you can see it, here's the endpoint that I'm sending it to /process. Now the problem is you have to confirm a subscription if you want notifications to be received. So we need to take a look at how that works. So inside of app, we've got the post process function here. So a message comes to us just as JSON in the request body, so we're just going to decode that directly, and then we're going to send it to our image transformer, and it will handle the message. So what's going on in there? The message comes back, so this is now our decoded JSON array. It will always have a type in it. Type is what is set by the SMS service for you to look at. If it is confirming a subscription here, then we fire up the SNS service and we send the confirmation of subscription message back. If it's type notification, i.e. the message we sent, then we're going to get the S3 service. We're going to get the URL of the object that we put in there earlier. We're going to resize the image. We're going to grammify it, and then we're going to store the gramified version back in S3, and then we are going to fire up DynamoDB. And DynamoDB is going to store a reference for us so that we are kind of keeping all of our data in S3, and then we're keeping an index in DynamoDB to refer to. So let's just have a quick look at the S3 service. So again, this is very similar. We're just making a call get object URL with the bucket and the reference name, and that will return a string to us. And likewise, the persist gramified one, we're just going in and we're doing create object. Instead of file upload, we're just passing the body of the object directly in there. So in the DynamoDB one, DynamoDB I used because it's all new and cool and NoSQL, and I probably would not use it again because it was just making my life difficult. So what we get here is we can put an item into our table. So you can see we've got a table name, an item with an image ID, upload date, message, and our gramified reference as well. However, this was the first thing that tripped me up, is this is what we need to do to create a table. So we use a hash key. This is kind of the equivalent of our primary ID, our image ID, which is a string. We have a range key element, i.e. the date, meaning that this is something we are allowed to sort and define limits and so on by. And then this is part of the service aspect of it. So you define the read and write capacity that you are expecting your service to be able to deal with, so that Amazon knows sort of how much power to provision for you. I think the batteries have died on this. Right, I'll just go over here and do this. Okay, so then we need to create our table. So again, this is a bit flaky. I'm running describe table on here to check that it actually exists, and then I need to sleep while it's active. So creating a table in DynamoDB does take about 30 seconds to a minute in my experience. So again, something that you would always want to do as part of your application setup, not as part of the request. Right, we're nearly at the really cool stuff. On our front page, we want to list the images that we have now stored in our DB. So we're going to call them grams, and our lister is going to fetch the latest grams that are available to us, and then just render them out into this twig template. So see what the image lister is doing then. So we fire up a DynamoDB service to get the latest grams, the S3 service again, and originally what I was doing, and this is another reason that I was a bit annoyed by DynamoDB, was I didn't have S3 at this stage. I was just gramifying my images and then storing them back in DynamoDB. But that was when I found out that DynamoDB can only really deal with quite small values. And not only quite small values, the size of the requests has to be quite small as well. So my original version of this had everything in DynamoDB. That just wasn't working out. So kind of as a hack, my DynamoDB is now just storing the references to the S3 objects rather than the objects themselves. This is why probably if I was doing this with a bit more forethought, I would go back and use something like SimpleDB to store these. Or maybe even just store them directly in S3 and use the listing of S3 to get the results back. But this does let me show you how to do a scan in DynamoDB. So you've got two ways of getting your data back out, a scan or a query. A scan is basically when you want to do an entire table scan and refine the list rather than pulling things out by the specific ID. So what we're doing here is we're telling it the table name we want, the attributes that we want, and then we need to put together this scan filter. Handily, this is one of the calls that the documentation just does not include any examples for. But that does kind of mean there are a large number of blog entries out there with people going, what the fuck? And then just giving you something like this that you can steal and change the table name so it works for your hacked up example. So what we're doing here is we're saying that we want to scan based on the upload date. We're going to use the condition less than or equal to, and we are going to compare the upload date to a number over here, and the number is the current timestamp. So basically what I'm doing is I just want to get back the most recent images. And then in the body there, this was another thing that tripped me up as well, is that when there was only one item in there, it was returning the item directly. When there are multiple items in there, it's returning an array. So I had to actually check the format of the response to see if I needed to stick it back inside an array again. So yeah, so DynamoDB feels a bit young, really, and I probably would not go ahead and start using it in a project. Okay, so just to jump back to that again to see what's going on, we get our grams and we render them out to a template. So I deliberately didn't show you what we were doing with the images and what we were doing with the templates because I thought it would be far more fun just to demo it like this. So we'll go off and we'll get Elastic Beanstalk here. So this is our front page now. You can see if you have used Twitter Bootstrap before, then this is just the default Twitter Bootstrap stuff. This app is live at the moment if you want to start playing with it. I will post the link at the end. So we're going to go to our upload screen, and we're going to upload an image for Amsterdamification. So we choose a file, elephant.jpg, and we say hello.dpcworld, and we upload that. Now what's happened here is when I've done that upload, we've sent that file to S3, and then we've posted a notification on the simple notification service with the reference and the message. That has hit our processing endpoint. Our endpoint has pulled down the JSON, pulled out the JSON from the request body, decoded that, gone back to S3 to pull the reference to the file down again, and then has gramified that, stored it in DynamoDB. So if we then go back to the home page, we see the results. So this is our gramified image that we have pulled out of there. So basically, that's kind of it. So what I can do oh, I could if I could find any of my windows. Does anybody have any questions in the meantime? Yes?
You think support for submodules to send to Beanstalk is coming quick?
When I was looking around, they were vaguely... So in the support forums, they say it does not support submodules, and we might look at doing it, but there was nothing saying that they are going to be doing it. Likewise, if you talk to Helgi from Orchestra, they have a similar thing as well. The Orchestra platform does not deal with submodules. What they suggest is that you actually push stuff into a separate repo, so kind of have your release repo where you store a conglomerated version of everything there. So you could do the same thing. You could have a release repo with the AWS push stuff where you just committed the result of a release, or you can do it that way and create the zip file yourself.
Is it possible to use the script on the different Git reposters of the submodule?
The AWS push is tied to a single application and environment. So if you did AWS push on one and then AWS push on the submodule, it would just overwrite what you had put there before, because you don't. It automatically goes to var www.html. You don't get to tell it where you want to put that information. There's a question over there? Yep.
That's a non-technical question. Do you have any experience in predicting the cost of setting up the infrastructure and for clients?
Okay. The calculator is kind of rubbish. The thing is, I mean, calculating usage for AWS is kind of no different to calculating usage for any other system. So being able to predict user traffic up front and the cost of a request of an application before you've developed it is really kind of finger in the air anyway. So we do very sort of ballpark figures, and actually, what I can show you is one of the reasons I really like the Elastic Beanstalk stuff is because whilst being able to do everything through the command line is really helpful and allows you to automate all of this, if you also need to get in and just deal with something really quickly, this is the scaling stuff that you've got available to you out of the box for the AWS stuff. So you can easily pick different things like CPU utilization, that kind of thing. So what we always say to clients is that we will give them a kind of rough indication of what we think the costs are based on whether it's dedicated or cloud. But then we always try and put in a load testing section at the end and say, this is where we will actually see the costs of these requests, and this is where we can make some decisions about how your budget is going to handle them. Any other questions? Yes? Yeah.
How much did this app cost you already?
I haven't looked. Let's have a... Oh no, this user won't have permission to look at the billing details. So I will tweet about it afterwards. So what I'll do just now is I'll stick this link up here. If you're using an iPhone, then you just won't be able to upload images, and that is your fault, not mine. But if you're using an Android phone, then you should be able to upload things from here. They are all anonymous, so don't start uploading pictures of penises and so on. Yeah. Just make sure that it's yours. Right. I think I've actually overrun anyway, but nobody has kicked me out yet. So are there any last questions? Yes. Yeah. Yeah, so it automatically sticks you behind an elastic load balancer instance.
So when there's high traffic, it automatically initiates another instance.
Yeah, so what I was showing here. So again, you can affect all of this through the JSON interface rather than through the visual interface. But is that readable? Yeah. So by default, it will always maintain one instance there. You can up that. It works the minimum instance based on the health check response. You can configure the health check as well. So you can tell it the maximum number of instances you want it to spin up in a sort of vague attempt to control your budget. You can tell the availability zones. You get the scaling cooldown time here as well. So if the indicators go high, it scales up. If the load trails off, it will be 360 seconds, and then it will start killing off instances to bring you back down to a minimum level. Yes?
You might also mention spot instances as a way to control costs.
Yeah, I saw that spot instances are actually being made available through Beanstalk now as well. I think that was a fairly recent development. I don't know if reserved instances are an option through Beanstalk as well either, but they are, yeah. Yeah, so by default, this is just spinning up a standard EC2 instance for you, but yes, the spot instances and the reserved instances have different pricing models, so you can keep costs down. Yeah. Yeah. Yes, so all of the AWS services I'm using exist as services separate from your EC2 instances. That was just because I wanted to demonstrate using the AWS services, but obviously there's nothing stopping you, say, running something like Redis on an EC2 instance. The next stage that I want to go to with this, which I was looking into, is these are just built from a number of standard AMIs, Amazon Machine Images, to fire up the EC2 instances. You can customize that AMI yourself so that you can run different services, do different things with the platform, and that's what I was looking at doing next, so that I could actually run kind of background services and cron jobs on the stack here, or maybe look at, because at the moment it goes through Apache, and I wanted to see if I could replace that with Nginx, but still be able to use all of this configuration. Anything else? Cool. In which case, I will post the joined in link via Amsterdam, I think, so you guys can see that. I'm probably not going to post the slides for this because they're all just screenshots and they still have my private keys in them. But what I will try and do is actually just stick this into a blog post with the instructions and stick the code up on GitHub. But please, if you have any questions, find me now, find me on Twitter, and thank you.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio.